Namaste. So, in part one of the programming paradigms series, I talked about the procedural way of doing programming. So, you organize your worldview in terms of a number of procedures. Procedures are just nothing but a sequence of steps or actions. For convenience, you group them into small, manageable units. People say that 10 or 10 lines, 20 lines, 30 lines, kind of limit for one procedure. It should be but logically meaningful. It's not number of lines per se. That logically one group of actions, one group of steps can be put together as one procedure, and then a bunch of these procedures can be, they can be nested again within each other. So overall, you get a procedural hierarchy, and that was the main organizing of your worldview. Okay, and there was of course data, which Simon said, may sit in files, may sit in maybe one tables, and it can sit in variable structures like data structures. So that's how the world was, and then slowly an alternate view emerged, saying, okay, we could, in the real world, there are a lot of entities, there are a lot of objects that has their own characteristics. So when you say a cat or a motorbike or a house or a human being so everyone brings into your mind some feel of what they do, what they are capable of, what they look like. So there is a the form and the behavior. So these two aspects are brought into your mind when you talk about the real world objects. So inspired by that, we were the idea came up saying that if we could organize the data not as passive data elements, but these data elements with associated behavior. So that led to the idea of an object, and then the objects were defined using classes. So languages were framed called the object-based languages, which meant that you could define objects, but you can also use your normal procedural programming style. Slowly, that went to almost a fully from object-based, we went to object-oriented languages, which meant that you have to define everything in terms of classes and behaviors only. So you can't interleave procedural programming with the object-oriented or object-style programming. So that again, people think that Java or C sharp is the way or object-oriented programming is to be done. That's not true. Languages like Simula is almost like 1960s kind of languages, which introduced the concept of classes. Okay, so the key point of object-oriented programming or object-oriented worldview is to view the object or the world as it is in terms of what are the key classes or the object classes, and attach their behaviors to those classes. So it kind of, that's what you mean by encapsulation or even abstraction. So when in a procedural programming, when you say a person, you only capture the basic properties, like a person can be a record which has a name and age and whatever. Whereas when you, in an object-oriented language, when you say a person, you can also define a set of methods, being born, doing an activity, becoming older, getting a job, whatever. All of these kind of things can be put as methods. So that together characterizes the notion of a procedure, notion of a class or an object. But the challenge was like, what should become a class, what should become a method or the behavior. In some logically, it seems pretty obvious that what is a class and what is an object, what is a method. But in programming terms, that became a challenge, particularly for those who are migrating from procedural to this object-oriented. This was a confusion. So there are a lot of guidelines about what should become a class, what should become a method. And I think there is still possibly a lot of openness about how that should be, what is the most appropriate or the best way of identifying classes and methods. But whatever that, we will leaving that aside. This caught on quite well, and I think it started with C plus plus, which came as an extension of C, and then Java became a refinement of C++, doing a ground up a lot of rework. So it was almost the first language to introduce the concept of an abstract machine, which is also nothing specific to Java per se. The notion of abstract machines existed even otherwise. Okay, so I'll talk about that maybe at another time. So with those things and a very sophisticated object hierarchy definition, exceptions, and inheritance and all that, it became a very popular language. And of course, a lot of commercial push and all that also got adopted. So Java became almost like the language, and today most people think that programming means writing Java code. So I want to get out of that feeling that any language is not the definition of programming. It's like you can talk in English, you can talk in Hindi, you can talk in Marathi, you can talk in Kannada or Malayalam, but what you talk and how you talk has really not much to do with that language specifics itself. There are nuances of the language, exactly like what happens. Writing Java code is different from C sharp code or C plus plus code or anything. But the organizing of the world, the organizing of the knowledge is what this paradigm actually brings to you. Okay, which can be ported from one to the other. So object oriented, became a big hit, and lot of and Java became almost like an overnight sensation, and everybody wanted Java. Today also, it is still very popular despite some licensing issues. So that brought object oriented programming as a very effective way to capture the real world complexities and being able to do the notion of classes and associated behavior also meant code reusability became a possibility. Potentially, a person class can be used by anybody who has to deal with a person as an entity in their program. And so it has nothing to do with the specific program task that I'm doing. So these were some of the interesting things that happened then. Now, along the way, there were a lot of other developments taking place. So, till their time, we were still talking about single process, single thread kind of execution. And it was like you do this, after that, you do this, after that, you do this, even though there is possibly no dependencies. And this you can see in an object oriented programming scenario. Every object that you see in the real world, they act independently, right? It's not like the objects are actually kind of waiting for their time slot to execute. And it would be nice if that could also be captured. Okay, and that is what concurrent programming was trying to do. And meanwhile, multi-core machines were coming in. Single CPU machines were not being adequately powerful, so we expanded that to multi CPU machines, what are called multi-processors, then multiple computers getting networked together called the distributed systems. They were coming in. So now the next challenge was, how do I program this kind of a contraption, this multi CPU, multi computer or multi thread machines? How do you program them? What are the challenges there? Okay, so that's my I'll talk about that in my part 3. Okay, so take care. And so, by the way, I'm in Kerala, and you can see some of the nice views that I'm able to bring to you through this medium. Thank you. Bye.